We do have 3 talks coming up. And the first one that we're gonna hear here in a bit is around AWS Orbit Workbench. And I'm super excited to welcome Igor, Adithya, and Olalekan from HRS Group. They've been working with AWS in implementing the open source framework, which is AWS Orbit Workbench in their environment. And we're super excited to hear a little bit how that is going, what they've been doing there. And just briefly, Orbit Workbench is an open source framework that gives you a unified experience UI for your data analytics and ML projects. So I'm really excited to see how they're making use of that. And as a second talk, we have Damon Cortesi today with us. He's a principal developer advocate at AWS, and he will give us a demo of Amazon EMR Serverless and EMR Studio, which is really exciting. And then we also do have Trevor Grant here with us today, Director of Developer Relations at Arrikto. And Trevor will show us Kale for Kubeflow, which I think also a lot of people are interested. We got a lot of questions about Kale when we do those meetups, especially in the Kubernetes Kubeflow environment. So super happy that we got Trevor today with us, and he's gonna show us a little bit more around Kale. So that's the agenda for today. And with that, I don't want to waste any more time and hand it over to, I don't know who starts, Igor or Adithya. Feel free to grab the screen share and yeah, maybe do a little intro of yourself, and then we're excited to hear the session.
Hello, I hope you can see my screen.
Yes.
So I will give some quick introduction about who we are and about which use cases we are trying to solve in our company. Hi folks, my name is Igor. I am product owner in the data platform team in the HRS group. Who is the HRS group? HRS group is a global tech company with a focus on business travel. HRS is one of the market leaders in the business travels market, and in Europe, one of the top 3 hotel portals. Our company is end-to-end platform that helps you to make data-led decisions to choose the best places to stay and work from around the globe. We're making travel easier by using our payments and expense capabilities to eliminate every manual step possible. Since we are data-driven company, we have a lot of data analytics that helps to make appropriate decisions in the future by using valuable insights. Before using AWS resources for analytics workload, a central BI team was responsible for managing analytic workloads for the entire company. This meant that this team was becoming a bottleneck. Apart from the organizational challenge, this also presented issues with infrastructure resources, since we had a lot of dependency on the on-premise infrastructure. That's why the data platform team was created. So our data platform team is responsible for scaling analytics workload beyond a centralized team of data experts. This implies that software engineers, data analysts, data scientists, and technical product managers across the HRS could work with data without any infrastructure concerns, focusing on innovating with data on behalf of our customers. To enable these data practitioners, to the data platform team set out to deploy a scalable solution based on self-service capabilities that allows its user to analyze massive amount of data. Then leveraging AWS resources for analytics, we were able to set up and manage our data lake on Amazon S3 with AWS Lake Formation and access it via Amazon Athena. The simplified design of our infrastructure is shown on this slide. And as you can see from this image, we suppose that the data consumer will use AWS Athena to query the data. But soon we observed that a lot of our data users, data practitioners, had no access to AWS console or could not cope with the cognitive overload of the tons of services. Hence, we decided to review some instruments that allows integration with our internal authentication and authorization tools managed by our DevOps team, by our internal infrastructure and security teams. That's why we decided to adopt Radash. Radash is a web-based SQL client which can be connected with our central single sign-on. This raised bar with data access, enabling everyone with an HRS identity to access and explore the data lake without downloading any additional software to their computers. Here are two highlights of this approach. The first one, our product operation team reduced the lead time to deliver a report shared with our sales enablement from 13 hours to less than 5 minutes with self-service capabilities that are available for them in Radash. The second highlight that our reporting analytics team extended Radash as a data exchange API layer on the data lake, and our other teams like CRM team can use this API layer to get the fresh data, to get the fresh reports, or even some JSON or XLS files, and put these files to the data pipelines or whatever tools that they have. So it allows completely remove previously existing central BI team as a bottleneck. At the bottom of this slide, you can see also some example of fancy dashboards and can be created in Radash. So we were quite happy with this approach, but I think we underestimated our data consumers because they wanted way more beyond SQL. They wanted to perform very complex transformations, joins, some analytical functions, and so on, so on. Some of such complex queries, SQL queries created by our data analysts can run for more than 10 minutes or even larger values. So this informed us that there were some underserved needs that our data platform features were not enabling. So our data practitioners shared the feedback with us, and we reached AWS and got to work. And with it, Adithya, our data engineer, will let you know what tool was selected to address such questions and share with you some technical details.
Thanks, Igor. Let me share. Sorry for that. Okay, so thank you, Igor. So myself, I'm Adithya Pathipaka. I'm working as a data engineer at data platform at the HRS group. So I'll be working with Igor and Olekan on building the performance efficient data pipelines and also creating self-service based applications so that all the users within a HRS group can access the data without any kind of blockages or any issues. So as Igor said, we have a kind of issues when we go with very high SQLs, like where we have a large amount of joins, where it could take a lot amount of time with the redash. So as Igor said, we had team up with AWS on implementing this Orbit Workbench. So what this Orbit Workbench means? So this Orbit Workbench is totally built on Kubernetes, where every processor or every notebook server will try to run on a pods. So this Orbit Workbench will try to provide us a Jupyter notebook where we can try to do all our related coding or data preparation or data processing within with the interactive setup. Okay, so this AWS Orbit is totally going to be run on a Kubernetes or like Jupyter notebooks, or it can run on Fargate. So this Orbit is going to deploy a secure team space. So it doesn't mean it means that we have every thing like so every team has its own space, so that other teams may not be interfered with their kind of development, and they can set up all their kind of data processing or data analytics, or everything can be done within the same group and same team space. Okay, so this was totally managed internally with the Kubernetes namespace, which is going to run EKS. So as I said, like every team has a secured team zone, and whatever the development or the Jupyter notebooks they are trying to create, so will be stored securely within the AFS, and only the specific team can access those related codes, and they can have a kind of interaction and work on the codes, and they can start building up the data processing or data analytics. Okay, so this Orbit was built using Python, and this development is totally like deployment is totally done using the Python CLI. Okay, so and also so as we also have a kind of requirement where the data science need to run their machine learning algorithms, which is related to image classifications and getting the information of the passenger, or who will be going to a kind of hotel. So these things we want to address with a kind of a single solution. That's the reason we came up with the Orbit with AWS. Okay, so why? So as I said, the benefits. So this can be used for the machine learning analytic purpose, where we have a specific teams, like each team has a specific resource, and they can start doing their kind of development, and this team space is totally secured. So once we have, so when we are trying to do the development, so we want to also make sure that this can be easily moved to production. Okay, so since we the team or anyone is going to develop any set kind of code can be stored securely and start doing the production kind of workloads in a span of seconds. So this Kubernetes, so what are the Orbit? So this as this runs on Kubernetes, so we can schedule the cron jobs related things. So within the Kubernetes, and that's going to trigger based on the schedule time we can we have set. So as we said, easily extended. So this Orbit has flexibility to creating resources within AWS, like creating a code repo, setting up a Redshift cluster or anything. So this can be easily done with kind of a set of plugins that are currently available, but also Orbit gives us a flexibility to developing new plugins, which are currently not, like if we want to have a new plugin related to data migration or anything, so which is currently not available. So you can directly go and start developing those plugins and have it available within the Orbit as well. Okay. So as we see, there are two kind of things here, like roles here. So one is a kind of administrator, and other is like a developer. So administrator is a person who is going to majorly take care of the infrastructure related, like based on getting the major requirements from team, and trying to figure out the capacity or the setting the related permissions that team should have access to, because as we come to data, we always make sure of the data governance, so that only the data that is required by the team need to be accessible, and remaining should be should not be accessible. So we have set so this gives an opportunity for us to create roles for each and every team and provide the specific permissions that the team require. Okay, as so that's what we see as part of administrator. But when we go to developers, that's what. So once the roles are being assigned to a specific team, so the user, when the user logins to a specific team, they is going to assume the specific role related permissions and start developing their data pipeline or data processing or any kind of machine learning algorithms. And once they start developing, once it's already, then they can easily move into the production within the Orbit itself. So so I'm going to show you a few things how this Orbit is being deployed. So what kind of foundation do we require here to deploy this Orbit? As a kind of basement or the foundation. So this total runs on Kubernetes. So we need to have a kind of VPC, and we need to have an EFS where we try to store the information that users are trying to create within the Orbit, and we use the AWS Cognitive User Pool for the authentication purpose. Okay, so this development. So what are the deployment we try to do here? It's totally based on a configuration file, which we call it as an Orbit manifest, where in this manifest, we try to give the information that is required to deploy, like information about the cognitive pool, EFS on VPC, and how many teams in that need to be deployed within the Orbit, and what kind of permission that each and every team, like, so providing, like giving the policies that gives a permission like to specific set of resources to that particular team. So if we go here, so this is what the manifest file looks like. So you can see what could be my Orbit environment name, what are my master roles, like an admin roles who has full access on the Orbit, so where who can try to control the Kubernetes cluster, or control the Orbit working kind of thing and everything. So we have a kind of splash bucket where when we go for the initial deployment, or when we try to deploy the teams, it will try to prepare a set of information that is required to deploy the teams or Orbit. And also we try to give the related EFS IDs, cognitive related ARNs, and if we try to have an SSO kind of thing like key clock or Octo, so we can try to configure within the Orbit, like within the cognitive user pool. And also we try to set the networking relay information, so where we try to give the public subnets, so where within the public subnets we'll be having the UI interface, like what we are trying to access, the Kubeflow dashboard or the Jupyter notebooks that is being deployed with this. Okay, and also we can set this custom domain. So if we have a internal domain naming, so if we want to add that, so we can also give those information and provide the SSL certificate ARN. So where it tries to access via HTTPS instead of HTTP. Okay, and also and the next we see managed group nodes. So this is the point where you all the data related, like data processing and all the operations that's going to happen within the Orbit will be running here. So in the next we have the teams. So this is the point where we try to create different teams within the Orbit. So we try to provide the name of the team and policies, like we are going to create a predefined policies before we try to deploy the Orbit, where these policies will have the information like what kind of resources does this team need to have access. Okay, and if this team has a like pseudo permissions, as I said earlier, so we have an EKS system master role. So this is kind of admin privilege for the EKS level. If this team needs to have like pseudo permissions on any of these EKs or anything, so we can try to give this. So only for the admin, but for the all the other teams, we will be setting this to false, so that they don't have access, or like they don't have access to change any kind of configuration on the EKS. Okay, and the Jupyter Hub in bonus, so this is going to update the security groups of each and every team that's going to deploy. It's going to create a specific security group in the VPC, so that they have access to the related IPs. If you want to limit a team to have a specific set of IPs or anything, so we can go and add it there. Okay, and also we see the EFS life cycle. So after every 7 days, it's going to just clear the related information that's not required, or clear the cache or anything from the EFS and do that. So in the authentication groups, so this is the main point. Like, so if a user wants to log in into the Orbit, so he may be available in one or two teams. So we this Orbit has set in a way that if the user is available in a specific group name and so team, so he need to be aligned within that particular group. and only then he can able to log into Orbit. If the user is not available in any of the groups that the team has been assigned, has been aligned with, then he will not be having access to Orbit. So this is the point where we given a secured access to the application and the data that is available. So if a user doesn't have is not available in any of the groups, so it means that he's not allowed to log into the Orbit itself. So he doesn't have any permissions to log in. So next will be the plugins. So this is a point where we try to give the information of what kind of a plugin that will like us. We need to have a kind of a code commit report or create a Redshift cluster or set up a SageMaker related operators available within Orbit. So we try to give this information here. Okay. So these are the plugins that are currently available. So where we can try to create the code commit report, Redshift or Redshift resources, and we can also create the EMR on EKS. So where it's going to create a kind of EMR virtual cluster on the EKS that is being deployed. And also script, it also deploys, we can have the plugin for SageMaker operators that's available as a for the K8. And also we have a team script launcher where this can could be a common thing, because there could be a sort of list of codes that a common code for each and every team. So we can try to set up a kind of code running from this team script, so that whenever a new pod is being launched or whenever the new user is going to log in, so what are the information is being set in this particular script is going to execute and have it available within the Orbit, within the Jupyter notebook. And also this gives Orbit also gives a flexibility to set up a kind of custom CFN and also has ability to connect to the Amazon FSx instances like FSx file systems, and also gives over provisioning for one of the teams. So where they can try, so when the number of users are being exceeded and we want to create any number of pods, so it's tried to do the kind of auto scaling internally, and it will try to provision the required resources. Okay, so as I said earlier, so Orbit provides flexibility to develop your own plugin, which is not available here. So if you want to have your own set of resources that need to be available from the Orbit, so you're happy to do the development and deploy it in your environment. Okay, so this is what the as I said, like Python is like the Orbit is totally built on Python. So this is a kind of a steps that initially we have to do to start as a preparation for deployment of the Orbit. So we need to have a kind of clone of the Orbit Workbench and properly select the related release, and we have to install all the required packages. So before it's like before 1.5 it was directly to PyPy, but the Orbit has changed to make sure that every user has a specific kind of user. So users don't need to wait for the changes to be released from the AWS itself. So if you have any kind of requirement that is not available, we can, if you know how way to make a code change, do the clone, do your changes accordingly, do the install required updates of the packages, and start deploying your Orbit. Okay, so this is what's so it's going to install all the required packages for Orbit. On the next, so once that is been done, so we need to deploy a code seeder. So this code seeder is going to set up a code build in the a code build where it's going to deploy all the required resources, like creating an EMR like EKS instance or all the other things. So this this code seeker, the code build that's going to deploy from this code seeker will try to do that. Okay. So so once this code seeker has been set, so we try to deploy the related images, which is a kind of a Jupyter Lab or Orbit controller or Kale related utils. So these three images are mandate, because so K8 utilities are the things where we have related helm charts related related information that need to be configured within the EKS. Orbit control is a point where it try to create the Kubeflow related information and do the authentication or any kind of the stuff that's going to run within the EKS. And Jupyter Lab image is the image where when users try to create a notebook server and start doing their development. So this is a point where majorly all the users will try to use it. So this so all these images, Docker images, will be deployed within your AWS account in the ECR repo. It's going to it's going to update every image over there. Okay, and next, once we have the images ready, so it's the time for us to deploy the environments. Okay, so first we are going to deploy the environment. So where this Orbit deploy and env is going to create the EKS cluster, and from the by the configuration which is given within the manifest file, and also and do the all the deployments that are related to K8 utilities on Orbit controller within this EKS. And also it also creates a specific a main admin related role, and that's been configured at this point of deployment, so that will be a kind of admin role to do any kind of changes or anything for the EKS cluster. Okay, so once the environment is ready, so this is the time where we are going to deploy our teams. So with this Orbit deploy teams, it's going to create a specific namespace for the team and do all kind of the EFS mount points within that namespace from the EKS to the EFS, and have all related information available in EFS, so that once a users try to log in, so the user will try to share the resources of that particular team namespace and start doing their development. Okay, so that's what we try to do the deployments. So with this with this Orbit, we have seen a very high level of adoption within our HRS group. So where we have like almost 6 teams who are kindly using Orbit, and we are spiking up with the pods of almost up to 300 to 400 on a daily basis, where they try to run all their data engineering stuff and data analytics and data science and machine learning related problems. So we see with this, so we try to create a single platform, so where the users no need to worry about if they have access to the AWS or not. So once they have access to Orbit, they come here, do all the related development or any kind of analytics stuff here, and start move that information to production and available for the business users. That's from my end. Thank you. So if you have any questions, and probably we can try to answer. Okay.
Yes, there have been a few questions in the chat. I think we tackled most of them. Chris, are there any open questions? I think you have been typing a lot here already, sharing. You've just went through the Orbit setup as well yourself, right?
Yeah, I've been going through this as well. Just trying to give context. And is there a demo? Yeah, we're doing a demo today, right? Just to tie all these concepts together.
I think this is totally related to kind of deployment, so we don't have a kind of demo here. Okay. Yeah.
Let's see. And then, yeah, Olekan, I saw you just hopped on video. Are you speaking next or wanting to say something? Go ahead.
I think I wanted to answer Samir's question. Do I need permission from my CTO to use Orbit? And if yes, how do I convince him or her? I think for us, it was relatively easy to convince the C-level about this decision. I think we first had a discussion with Antje. And then, like Igor rightly mentioned, we have queries running, at least on Red Ash, we had queries running for 10 minutes and beyond and above. And we had users who wanted to do complex analytic functions, right? So I think that's the unique sell, and the fact that it's open source was another way that we easily could convince them. And looking at the initial validation of the value, which is, you can see probably we didn't spend time so much into it, but we went from, I think, 0 to 300 pods, people running analytics on their own, even teams that are non-data teams, for the lack of a better word, that means teams that are not part of our central data analytics organization, now using Orbit for their analytic workloads. And this is how to convince your CTO. Right. When you see a software engineer from a different team who's probably maintaining a different product, saying that they need access to Orbit because they want to analyze their data that they're pumping into the central data lake, then you know that you're in for a company-wide transformation when it comes to analytics.
Yeah, and let me share my screen real quick, and I'll spend about 5 minutes just showing what this thing looks like. I think it'll help pull things together a little bit. Let me get out of there. Can you see my screen?
Yes, we can see it.
Okay. So, for example, and I'm zooming in like way too much here, but here's so this is like an environment that I stood up on one of my many domain names that I have had since 1995, I think, is what this flux capacitor goes back to from college, I think, or maybe after college. An example here is Lake User. So these are the different admins. So this is kind of a reference architecture, or sorry, this is a demo environment. And this environment here, there's some, data lake admin, there's data lake creator. So the creator creates the data lake. If you already have one, of course, you don't need to create, you would just fire it up. Lake admin can perform admin tasks. I don't use sample admin, but Lake user, this is really what most of us would be coming in as. And as you see, it's using Kubeflow, which I was really excited about. The initial version of Orbit, I don't think even used Kubernetes. And when they went to open source it, the team, this comes from professional services team, they decided to make a Kubernetes base to sort of broaden the use. And then we were working with them about Kubeflow, and they decided to pull Kubeflow in, because once you have Kubernetes, Kubeflow is just an add-on. So we can do Kubeflow pipelines, we could do notebooks. I have this notebook up here. Click in. If you've ever seen Kubeflow, you'll know this is pretty familiar. And this is just a regular Jupyter notebook that we have added the Orbit, things along the left side. So Orbit gives you access to Redshift, gives you access to the Glue catalog, gives you access to SageMaker. So here I can run notebooks as jobs. And that's something actually that like Trevor is going to show us in the third talk, how to do that actually a different way using something called Kale. And at some point we will likely pull Kale into Orbit as well. That's actually one of the reasons I asked Trevor to come, so I could see where the project is so that hopefully we can pull it in. But there's lots of cool demos here. You can even launch AWS Glue Data Brew. Now this is a really, really cool project or service rather, where you can embed it into any of your applications. So this is actually on the Glue development side on the AWS Glue team, and projects and recipes, and we can do transformations and drill in and take a look at what these transformations look like. I think I'm zoomed like way out here, and this is all sample data here. So then I can look at data lineage. And just to reinforce the concept of a team. So, team is a layer on top of the individual user. And so you can lock down data at the team level and jobs. And so it was introduced as an add-on into Kubeflow and to Kubernetes to give an extra layer of grouping. So here I can look at my persistent volumes if you're familiar with with Kubernetes, you'll likely understand that, what these volumes are. So I don't really have anything running right now. I've been actively trying to figure this system out and get everything going, but that's what it looks like. I believe I can pull up the Glue catalog. Why is Glue catalog not coming up? And this will actually show the Glue data catalog and which tables you're actually able to see. So that's what it looks like.
Thanks a lot, Chris. Just to add, what you can also do within Orbit is that we mirror the setup of our data lake into AWS Orbit, such that a team has access to a specific, because we design our data lake with lake formation, and then we organize it based on teams as well. The concept of teams is very important to us. So the data that you have access to as a team, as in a particular team, let's say team A, if someone else in team B logs in, the person might not even see the data at all. And that ensures, even from not only from the EFS perspective, but also from the data catalog perspective as well, we mirror that data access on a secure level with lake formation also within Orbit. So you can do all that separation of concerns to ensure that people only see what they're meant to see, not just seeing everything. Even though we're federating analytics with Orbit, we do it very, very securely.
All right. Yeah, Antje, do we have any more questions, or are we ready to move on to Damon?
Yes, I think given the time, yeah, one question coming in, can you suggest a tutorial or sample lab project to get more hands-on on Orbit? Yeah, that's definitely the link we're going to reshare here to the GitHub that has instructions how to get started if you want to do a demo setup and play around with it. And we'll share that in the chat here again. All right, thanks so much. Really appreciate your joining us here from Germany late on a Monday evening. Igor, Adithya, and Olekan. Thanks so much for sharing your journey here with Orbit Workbench. And with that, I'm handing over to Damon Cortesi, who will walk us through Amazon EMR Serverless and also show us some exciting new things there. Damon, the stage is yours.
Awesome. Cool. Hello, everybody. I'm Damon, coming to you from Seattle today. So it's a beautiful, dreary day here in Seattle, and I'm on the EMR team as a dev advocate. I was previously on the EMR team as a big data architect, so I often helped customers kind of build, design, prototype, and eventually debug their EMR deployments. And today I want to talk to you about EMR Serverless. Before I dive in, I'm terrible at this, so I'll do a little bit of shameless self-promotion. I've got a whole bunch of different EMR videos on my YouTube channel, C to Court, so go ahead and check that out, subscribe, and I post new stuff a few times every month. My most recent one is about modern data lake storage layers like Apache Hoodie and Iceberg and Delta Lake, which you've probably heard about. So I dive in a little bit and talk about how those things work, what they do under the hood. So feel free to check that out. And then a lot of the stuff that I'm talking about today is on my personal GitHub. So again, it's to Court, and I've got a demo code repository. I will push up the code that I use for today's demo after I wrap up today. So without further ado, I will go ahead and hop into a little bit of a PowerPoint and talk about what EMR is and what EMR Serverless is, and then we'll jump into the demo. All right, let's get started. So if you're not familiar with EMR, EMR has been around for quite some time. I think it was one of the original 10 services that AWS put out. And it was originally called Elastic MapReduce because that's exactly what it was. It used the Hadoop framework, and you would supply a Ruby mapper script and a Ruby reducer script, tell EMR how many instances you wanted to spin up, and it would go ahead and spin up all those EC2 instances, run your scripts, and dump the data back to S3. Since then, in the past decade, the data world has evolved a little bit. And so EMR is more commonly known today as a way to deploy and operate and manage these different big data frameworks on AWS. So whether it's Spark or Hive or Presto or even HBase, you can go ahead and essentially at the click of a button in the EMR console, deploy these services to AWS, spin them up, and run them and auto scale them and scale them up and scale them down, all at the cost per second that you desire. So one of the big things about EMR is we try to keep up to date with the latest open source frameworks. So within 30 days, if there's a new release of these different frameworks, we try to get that out on EMR as well. So that includes things like Flink and Hoodie and Spark and whatnot. In addition, one of the things we've been working on the past couple of years is EMR runtimes for some of these different frameworks. So for Spark and Hive and Presto, we've got custom runtimes that are 100% compatible with open source, but add performance to those native frameworks. So Spark, for example, can run two times faster, 2.5 times faster as compared to open source. So just by running on EMR, you get a lot of those benefits. And then you can also save costs with spot instances and things like that. So that's if you're running on EMR and EC2, which is kind of the original EMR. And I'll talk a little bit about the new deployment models that have come out in the past couple of years. There is, of course, S3 storage. So as everybody's moving to data lakes, data lake houses, whatever you want to call it, EMR, of course, can process that data in S3. One other thing to kind of call out here is we've done additional work to make it possible to use S3 with frameworks that might not natively support it. So HBase, for example, historically you had to have HBase on top of HDFS, but with EMR you can use HBase with S3 as your backing store. So that's really great if you don't want to have to manage a whole bunch of HBase servers and manage the uptime. You can actually spin an HBase cluster up, spin it back down, and all the data is stored on AWS. And then finally, easy and scalable, right? So it's fully managed. You can go in there, click start. We take care of provisioning all the instances. If an instance drops out, we'll replace it, of course. And there's vertical and horizontal auto scaling. So you can choose your instance types and you can click the auto scaling button. And based on your workload, we'll add more instances or take them away depending on what that looks like. So that is a brief overview of EMR. I know I went through that really quickly, but I think that the main takeaway here is it's a way to run these big data frameworks easily in the cloud. So it used to be you just had EMR and EC2. The world has evolved, of course, and now there are multiple different deployment options for EMR. So EMR and EC2, you pick the instance types that gives you the best performance or cost for your workload. So you can choose high compute, high memory. If you have GPU instances, you can pick those, or Graviton 2 if you have a Graviton 2 compatible workload. So you can really mix and match and tweak and tune as much as you possibly can. You can use custom EC2 instances if you want to. You can go in there, you can SSH in or what have you, and customize those to whatever degree you want. A lot of folks in the world are moving to Kubernetes. So EMR also supports EKS, and you can easily run your EMR Spark jobs on Kubernetes. And that takes care of automatically provisioning the pods. We take care of a persistent UI for Spark that can run there, and you can monitor your jobs as they're going on. So this is a really nice option for folks that are moving a lot of their workloads to EKS, as you can now run EMR on EKS as well. And so you can use Kubernetes to run your Spark workloads. We do see a lot of folks that are moving to Kubernetes, of course. So this is a relatively recent option in the past couple of years, but definitely gaining more popularity. And then, of course, the thing I'm going to talk about today, EMR Serverless. So this makes it even easier to run analytics using the latest open source frameworks. So with serverless today, we support Spark and Hive. Presto is coming as well, but you don't have to configure, optimize, secure, or operate clusters. You really just start an application and submit your job, and that's about all you have to do. So pretty awesome. And like I said, I've been with EMR since about 2017. So I was there before we even had this fancy EKS Kubernetes option. It's just been interesting to see the evolution of EMR, right? We're trying to make it easier to run. We're trying to make it more developer friendly, and really trying to take away all the pain points of running your Spark jobs or your Hive jobs on the infrastructure. Finally, on the bottom there, we've got AWS Outposts. So if you're using Outposts to run AWS in your on-premises environments, you can also run EMR there too. So there's a lot of different deployment options. I'll go through the top 3 just to talk a little bit about what they look like. Before I do that, just to talk about serverless quickly, you can run it in addition to these different modes. Makes it easy to run Spark and Hive. no servers to provision and manage, and you can run your data engineering pipelines or ad hoc workloads through there. We don't yet support notebooks on top of EMR Serverless, but that is something that will come as well. All right, so with the EC2, EMR and EC2 is really a cluster-centric model. You run a single version of Spark per cluster. There's a shared execution role, and it's great for jobs with cluster scoped dependencies. So there's a couple big ways that people run EMR and EC2. They either spin up a big cluster and have lots of different jobs running on it at the same time, or they'll spin up a cluster, run a single job on it, and shut the cluster back down. And it's great for doing that when you know exactly how you want to run the job on your cluster and it's running at high utilization. On the right-hand side here, you can see all the different pieces of EMR and EC2. So there's the EC2 instances where we take care of provisioning those, but you're responsible for managing security updates and things like that. There's Yarn, the resource manager, Spark and EMR, and then of course your application and dependencies. Flipping over to EMR and EKS, when we take things and containerize them, it drives a job-centric model. So with EMR and EKS, you submit your job, and you can run multiple versions of Spark on the cluster. You have a per job execution role. So each job can have different permissions as opposed to the whole cluster having the same set of permissions. It's really good for quick test and upgrade cycles and consolidating resource utilization, of course. On the right-hand side here, you can see, EKS manages the operating system and the EC2 instances, as well as the Kubernetes control plane. EMR takes care of Spark and EMR specific components. Then again, you take care of your application and dependencies. And I tried to make this as stark a difference as possible, but with EMR Serverless, EMR takes care of the Spark runtime and EMR specific components, and then you just run your application on top of it. So again, pretty simple to use, no clusters to manage. You get a per job execution role again. Resources automatically scale up and down. So Spark has something called dynamic allocation, and that's enabled by default on EMR Serverless. So when you submit your job, the Spark job will run, and as it runs, it will decide if it needs more resources or not. And as it asks for those resources, EMR will automatically go ahead and scale up the cluster and give you those resources. One other thing about serverless is there's something called pre-initialized capacity, and you can use that to start jobs instantly. So essentially you have a warm pool of capacity you can use to start your job. The other thing that I mentioned, we do have the EMR runtime for Spark. So this is on a benchmark on Kubernetes, but you do get about a 2x performance boost with the TPC DS benchmark, just using the EMR Spark runtime. So I said, we've been putting a lot of effort into just making Spark run faster on EMR, so you get some automatic benefits there. All right, so with that, I'm going to flip over to the demo real quick. And before I do, let me go ahead, EMR Serverless preview. If you do want to check out EMR Serverless, it is in preview right now. So that means you have to sign up and gain access through that way. So you just go to this link here, the EMR Serverless preview link, and fill that out. And we are currently letting people in about once every couple days or so. So go check that out if you want to gain access to that. And then, yeah, let me get started. Before I do, there is a question about, will EMR Serverless support Livy? I don't know if it'll support Livy specifically, but I know that it will submit, you will be able to connect to, at the very least, you'll be able to use EMR Studio to connect to EMR Serverless. So EMR Studio is a managed Jupyter Notebook environment, so you'll be able to use that. I'm not sure about Livy. I think it, depending on some of the feedback that we get during the preview, we'll see how that all kind of shakes out. But the goal is to be able to support certain long-running apps like Livy or Presto, or interactive apps like that on EMR Serverless, so you don't have to worry about managing clusters. So that's kind of the long-term goal there. All right, let's go ahead and get started. All the demos that I'll be using today are in EMR Serverless samples on the AWS Labs repository. So once you gain access to the preview, you can use this along with the documentation to go through and kind of run some different examples. So all these examples, there is no console yet for EMR Serverless, so all these examples are going to be in the command line interface. So what we'll do, I've got a bucket here called my EMR Serverless demo, and I go ahead and clone this EMR Serverless samples repository. I've already done that. And you can see there's my serverless samples repository right there. The first thing we need to do with EMR Serverless is create an application. So this application is the construct of what type of job you're going to want to run. And we support today both Spark and Hive applications. So it's pretty straightforward. You just go ahead and do an EMR Serverless create application, specify the type, the name, and then the release label you want to use. And this is the EMR release label, and that ties back to the version of Spark. So EMR 6.5 is Spark 3.1.2. One thing to note here, you can optionally specify your initial capacity and maximum capacity. This is the pre-initialized capacity I mentioned. So if you go ahead and specify initial capacity, what we do is we'll keep a warm pool of instances running with this configuration. So for Spark, the initial capacity here is a driver worker count of 2. That means 2 Spark drivers will always be sitting there ready and waiting for you to submit jobs, and then 10 executors as well. EMR Serverless still will scale up automatically, but that just means your jobs will start immediately. So I've already gone ahead and created that application, and usually it spins up in about a minute or so. Let me just double check and make sure. Oh, I need to go ahead and start it again. So I'll go ahead and start that one. I've got a Spark application. So I just go ahead and do a start application. I'll go ahead and start my Spark application. And I'm going to do the same with Hive too. So I'll do a start application on my Hive ID. You can, of course, also start an application, start a Spark application without pre-initialization. So that 4 lines right there. That's the command you would use to kind of start an application without the pre-initialized capacity. And all that means is that the application won't have the resources kind of sitting there ready and waiting. So when you submit a job, it might take a few seconds or a minute for it to go ahead and provision the resources necessary for that job. So that's kind of where that pre-initialized capacity comes in. So let's go ahead and see if those applications have started yet. They're both still in the starting phase. And just for fun, let me go ahead and create another one here. And we'll see how fast this one goes from there. So we need to do a get application and then a start application as well. And that's still creating, so it'll take a second to go from creating to ready to start. Cool, so that's in created now. If I go ahead and start that one, now I've got 3 different Spark applications, or 2 different Spark applications and 1 Hive application, all kind of starting up and provisioning behind the scenes. So what I want to do first, oh yeah, the other thing you need is a job role. So if we go back to the README here, there's a job role that you need to run your EMR serverless jobs. And you just need to grant it the access you need to run your job. So whether that's access to S3 buckets or access to Glue, you just need to create a role that has that access as well. So what I'm going to do, I'm going to use one of my favorite data sets, the NOAA Global Surface Summary of Day data set. This is part of the registry of open data, and it's a data set that allows you to, there are daily weather readings, essentially, you can get access to and do some fun stuff with. So let's go ahead and do a quick list of that directory. So if we do an S3 LS of the NOAA bucket, we can see there's data for every single year. And if I do 2022, and let me just do a quick summarize of that data and tail, because what we'll see, whoops, need to add the slash there. That'll take just a second to come back. And what we'll see is we've got almost 12,000 objects in there, 12,000 CSVs of weather data totaling about 120 megabytes. So fairly typical data science situation where you've got a whole bunch of CSVs and you want to be able to process them, right? So what I'm going to do, I've got a PySpark script and a Hive script that I'm going to run on EMR Serverless that'll kind of comb through the year and show us some extreme weather situations. So let me see if those applications have started up now. Awesome, the Hive one is started and the Spark one is started. So the start is something you only have to do this one time, and then the application is there ready and waiting. So let me go back to my code here. And let's go ahead and submit a job. Let me pull up that extreme weather script. I'll go ahead and I'll submit this job. In this case, we're going to do EMR Serverless start job run. You specify your application ID, the job role, and then the job driver. So let me go and paste that in. A few things to call out here. Actually, let me do job run ID. And then I can do a get job run, because I think it's probably already going to be running. So the job is already running. So you can see the start time there is faster than I can type. My finger's a little bit cold, so I'm a little bit slow this morning. So we can see up here in the start job run, a few things to call out. You specify your entry point. So this is just your PySpark code in an S3 bucket. And I have specified my Spark submit parameters here, my different driver cores and memory. These are optional. You don't need to specify these. The one caveat here is if you want to be able to use your initial capacity effectively, you will need to make sure your Spark submit parameters fit inside that initial capacity. So my initial capacity, I think I had 4 cores for the executors and 4 gigs of memory for the executor memory. So I just needed to make sure for that to start instantly that my Spark submit parameters fit in there. And then we're going to log our data to S3 as well. So if we do a quick S3 ls of our Spark logs, the Spark driver logs aren't there yet, but we will see the Spark logs directory here. And this is Spark logs for the app UI. So you can see all the different Spark logs that are starting to already get spit out to S3 there. And pretty soon we will see Spark driver logs coming out there. Do a quick get job run again. And we can see it's still running. This job, it's going to go ahead and list some of the files on S3 and then do some of that data. So one thing to note as well, while EMR Serverless is in preview, there isn't a Spark UI, but you can run a Spark UI locally. So in this EMR Serverless samples repository, we do have a Docker file you can use to build a Spark UI. It's based off EMR and EKS, so you do need to log into the ECR repository for the EMR on EKS image, and then you can just do a Docker build of the Spark UI. So that goes through, does that whole build, and then, oops. And then we can go ahead and export our log directory. So these are the Spark logs that we saw before, and then run the Docker image. And so that'll go ahead, spin up that Docker image, and it should connect to S3 here in just a second. And we can see it's downloading some of those Spark logs from S3. So if I go over to my browser and open up localhost 8080, it'll be under incomplete applications. And you can see here, here's my extreme weather application. And I can click into that app ID. And this is all reading the data from straight from my logs on S3. So as the job is running in real time, these logs are pulling from S3. And we can see it's in the middle of this CSV thing. It took about a minute to list those 12,000 files on S3. And now it's going ahead and doing this CSV thing. And if I click on the event timeline here, we can also see it added a few more executors during the course of the job. So right around here, these are the first 10 executors that I requested. And then using dynamic allocation, EMR Serverless automatically requested another 90 or so executors. You can see it got up to 92 or somewhere around there. So as the job is running, EMR Serverless is using that feature to go ahead and just request those new executors and add capacity to the job. So I don't even need to specify, too many details about what I want there from a Spark perspective. EMR Serverless is going to go ahead and take care of that for me. And this job should finish up. It actually just completed here, did a few counts and whatnot. So I think that is all done. So if I go back to my console, I'm going to quit out of my Docker UI here, and I'll do another S3. Still trying to read some data. S3 ls of my log files. There's my standard error from the Spark driver, and pretty soon I will see some standard out there too. And that is pretty much how easy it is to run a job on EMR Serverless. So get the code on S3, start an app, and run your job, and you're off and running. So definitely a lot easier than trying to figure out if you need, you know, R5 4XL or C5 24XL or what have you. If you just want to run a Spark job or a Hive job, pretty darn easy. And then if we do a copy of those logs, I'll do my standard out log. I can copy that locally, gunzip it. And we can see the output from our jobs. The amount of weather readings in 2022 is 500,000. Pulled out some extreme stats. The highest temperature so far has been 131 degrees Fahrenheit. The highest wind gust was actually in Mount Washington, New Hampshire, so almost 100 miles an hour last month. So pretty easy to go ahead and do that. There is a question in the chat about connecting Jupyter Lab. You can't, today, Jupyter Lab doesn't connect directly to EMR Serverless, but you can run AWS. You know, if you have the AWS CLI in your Jupyter Lab, you could certainly run AWS CLI commands. We are looking to add support to be able to connect notebooks to EMR Serverless. So that's something that'll probably come at once EMR Serverless is generally available. But right now in the preview, it's just CLI only. All right, so let's go back to my code here. So we did that. That's running a Spark job and using the Spark UI. I'm going to go ahead and run a Hive job as well, just to demo that. This one will be pretty quick. The Hive job is pretty similar as well. So we have our extreme weather SQL script now. And this is also going to query the NOAA GSOD PDS table. And it'll do some conversions there to pull out max temp and wind speed and pull out all those different attributes. There is also a create table script. So with Hive, you can run a script before your actual execution script, and this just creates an external table, NOAA GSOD PDS. And this is going to create the table in the Glue data catalog. So EMR Serverless also supports Glue. So I'll go here, I'll do a start run job, and I'll paste this in and then talk about it. Cool. Let me do an export job run ID there. This is pretty similar to the Spark code. We provide our initial query file. So this is the create table script, our actual SQL query script. And then with Hive, there are a couple required parameters, this scratch dir and this Hive metastore warehouse dir. You just need to point to locations on S3. These properties aren't required, the Hive driver cores and memory and whatnot. But again, if you want to make sure you use the initial capacity, you need to specify those there, and then of course your Hive logs output. So I'll do a quick get job run here, and we can see that that job is already running. So in terms of job startup times, it really depends on what capacity you're requesting. So, and if you're using the initial capacity. I don't have the numbers off the top of my head in terms of benchmarks, but we've certainly been doing some benchmarks on how fast these jobs start up and acquire new resources as well. So, if you're using initial capacity, we will keep that capacity warm for you. And once you submit that job, as long as that job fits within the parameters of that initial capacity, it starts within seconds. So if you're not using the initial capacity, we do have to go and of course, fulfill those capacity requirements. And so if, I forget the exact benchmarks again, but the more resources you request, of course, the more time it takes to spin those up. But, from my experience with EMR over the years, I've been pleasantly surprised with how fast it's been. So sorry, I don't have more details there, but that's kind of where we're at right now. So again, if we look at S3, we'll see our logs for the Hive job start to populate. And similar to Spark, we can use the Tez UI to go ahead and do this. So I actually have that Docker image built already. There are just a few different environment variables to specify for the Tez UI. And I think I got that job run ID. So we just go ahead and again, do a Docker run of the Tez UI. And again, once we go GA with EMR Serverless, we intend to have these UIs in the console for you to be able to go and click on and run, so you won't have to run local Docker images and pull data out of S3. All right, so that went ahead and started the Tez UI. See if I can access that. And I don't know if there's enough data in there quite yet, but that should pop up pretty soon as more data populates on S3. But I won't wait on that to get started. That's just an example of how you can pop open that Tez UI and keep an eye on that Hive job as well. If I do an S3 LS of that again, let's see what that looks like. Oh, we can actually see there's our Hive driver right now. And we've got a standard error and our Hive log. So let's go ahead and copy that down. Hive.log.gz. We'll gunzip that again. And that's pretty verbose. You can see a whole bunch of stuff going on there. Looks like it might have succeeded already. Let's do a quick copy of the standard error just to see what that looks like. These are all the states the reducer is running and all that kind of stuff. So you can get a little insight into how that's running. But like I said, I won't dive quite into that. I do want to do a quick demo of EMR Studio as well. So let me go ahead and hop into that. So EMR Studio is a relatively new addition to EMR. If you're familiar with EMR, you've got your clusters over here where you can create a cluster and choose your instance types and all that kind of fun stuff. If you go up here on the top left, you can see EMR Studio. And if you just go ahead and click Get Started, you can create an EMR Studio from here. So a couple things to call out. If you do create a studio, there are some additional things in here that you need to take care of, like you need to create a subnet for the studio and service role for the studio. But we do have a GitHub repository out here that is AWS samples EMR Studio samples. So this includes a couple of CloudFormation templates to go ahead and launch EMR Studio, as well as some other examples in there too. So if I go in here, I've already created a studio, of course. And when you go ahead and create the studio, if I click through to that, you get a studio access URL. So this is, you can log into this using your AWS IAM credentials, or EMR Studio also has support for SSO. So if you want to use a third-party system like Okta or something like that to authorize your users into EMR Studio without having to log into the console, you can totally do that as well. In the studio, you can create a workspace. This is essentially a Jupyter Lab environment for you to be able to hop into. So you create your workspace name. We do allow you to do workspace collaboration. So this actually means two people can be in the same Jupyter notebook, even typing in the same cell. It's a pretty sweet little feature there. And then you can also connect that workspace to an existing EMR cluster. You can create a cluster directly from here using this simple interface. There is a thing called cluster templates, and that's pretty nice because you can actually predefine templates for folks that want to be able to create clusters of a specific type. So if you have data science folks that want to create specific clusters or whatnot, they can just create a cluster template for them. EMR Studio also supports EMR on EKS. And eventually there will be another little box here for EMR Serverless. So I've already gone ahead and created that cluster. What we can see here too in EMR Studio is you can also manage and look at your clusters. So it's a little bit of a simpler interface for managing EMR and EC2, for example. You can go in here and look at the cluster and the state, and you can also launch application UIs from here, like the Spark History server. You can also see your EMR and EKS clusters. I don't have any in this account, but that's something else you could do there. So when you hop into your workspace, you land here in this nice little Jupyter notebook. We just did an upgrade recently to Jupyter Lab 3.1.4. So pretty recent with Jupyter Lab. And this is what you get when you land here. By default, you can use Python 3, PySpark, Spark, and Spark R kernels, but you can, of course, add your own kernels to the EMR cluster. I've added a Julia kernel, for example, if there's any Julia fans out there. So once we're in here, pretty straightforward as well. You can just hop into a notebook and go ahead and say print hello. And there we are. So we've got our Python 3 kernel. You can use AWS CLI commands in here too. So I can do like S3 LS of that NOAA GSOD PDS bucket. We'll go ahead and query S3. And so that is where that kind of comes from. You can go ahead and run those commands. You can also go ahead and switch the kernel. So we can switch over to PySpark. We can run that kernel. And we can just say, let's go ahead and do a spark.read.csv of that. I'll do a df.show. And we can start our Spark application. Looks like somebody has a question that they keep raising their hand. If you do have a question, just go ahead and paste it into the chat, and we can see it from there. So this is going ahead, connecting to my EMR cluster that I already have running in the background, and starting up a Spark session and reading that CSV data from the S3 bucket. I will show, and you can see there's this nice little widget here where we can see what's going on. But if you want to look at the actual Spark UI, you can go to this thing here and launch the Spark history server straight from there. So this should actually pop out the data pretty quickly. And there is the CSV data. Probably needed to specify my header equals true option, but that's fine. With EMR Studio, we also support different languages in the same notebook. So you could do something like Scala Spark and type your Scala in there as well. So if you wanted to mix and match different languages in the same notebook, you can do that too. And then this new tab that just opened, this is my Spark history server. And you can see here, if I show my incomplete applications, this is my EMR Studio session running right here. And I can kind of click in here and dive in and see all my Spark logs from here too. So with EMR Studio, I don't have to SSH into a cluster. I don't have to manage or operate those. I can do everything kind of from here. And like I said, I can log in with SSO as well. And let's do one last fun thing in our EMR Studio. So I have this weather day notebook, and I love weather and I love weather visualization. So this notebook is going to go ahead and install some dependencies. So I can do a pip install inside the notebook itself. I'm just using Python 3. We get all our favorite libraries here like matplotlib and numpy. I just do an S3 install of the, or a pip install of those. And then let me go ahead and just do a run selected cells and all below. So what we're going to do, there's another set of weather data out there, this ERA5 PDS weather data. And this allows, this gives us some more detailed look at weather data. So I'm going to look at precipitation data, and I'm going to build a weather map of weather data for a given day. So we go and we read this data. I'm going to pick January 1st of this year. And then we go ahead, open up that data from S3 and build some precipitation data, pressure data, and temperature data. And then once that finishes, we're going to go ahead and draw this pretty map down here. So I'll do a matplotlib inline. I won't dig into all the code. It is available out on my GitHub. But what we end up with is this beautiful little weather map that shows you what the temperature and pressure looked like on January 1st of 2022. So just a quick way to see how you can do a pip install of libraries inside of EMR Studio and be able to do that. If I want to, I can go ahead and change that date. Maybe we want to do, let's say 2021-08-01, run selected cell and all below. And that'll take a little bit of time just to read in that data. And down here, that'll show up pretty quickly. While that is running, I'll just pick out a few other features over here. You have your clusters that you're connected to, either on EC2 or EKS. You can detach and reattach to a different cluster. This is great if you've got like a dev cluster or a prod cluster. You can also create clusters directly from this interface as well. So you can go ahead and do that. There is support for GitHub as well. So you can go ahead and add a new Git repository. So you can connect to public Git repositories or private Git repositories, and those will get synced into your EMR Studio, and you can push changes back up to there. And you can see my weather map generated there. So clearly warmer over the US for those dates. And apologies for the proper projection there of the US, but it's not too bad. And then some other things to call out in here, there are a bunch of notebook examples in EMR Studio as well. So if you want to learn how to do some linear regression or query a Hoodie data set or query Redshift, we have a whole bunch of different examples kind of built into there. And there's a new feature that just came out recently as well, where you can use a SQL Explorer. I need Presto installed, so I have a cluster that has Presto installed. But essentially, you can browse the Glue data catalog inside of EMR Studio and write SQL queries against the tables in the Glue data catalog as well. So in order to do that, I needed a cluster with Presto, but I just spun up a Presto cluster here, and I can click attach. And so this just goes, detaches from my old cluster, attaches to that new cluster. And those new clusters can have different libraries on them or different things like that. I'll go and do a quick reload. And I think I will just about wrap up once that's done. So I can go down here. Awesome. I don't think I have actually any, I don't have any databases in this in this region right now, but if I did, they would show up there. I could browse those, and then I could open up a SQL editor and just write some quick SQL code there. So the last thing I will call out, if any folks here use SageMaker, SageMaker Studio recently added support for deep integration with EMR, so you can create EMR clusters from within SageMaker Studio, and you can also manage those and look at the status of those clusters and all that kind of stuff directly from EMR Studio, or sorry, directly from SageMaker Studio. So some nice tight integration there from folks that are using SageMaker and Spark to do their data processing. And I think I will wrap up there and see if there are any questions.
Perfect. Thanks so much, Damon.
Yeah, a lot of stuff to talk about, but
a lot of stuff. Yeah, a lot of news around EMR. That's great to see.
Yeah,
I
definitely.
see a few folks have their hands raised. If you have any questions, feel free to put them in the chat window here. Damon is going to stick around for a little bit longer, so we can answer your questions.
Yeah, there's one question there about how soon the preview is allowing folks in. We're allowing folks in every few days in the preview, so you should get access to the preview within 2 or 3 days. And as soon as you get that, you'll be able to, you'll need to download a model file for your AWS CLI. The APIs are not part of the public CLI yet, so you'll just need to download that model file, and then you can get started submitting your jobs.
All right. Any more questions? And again, yeah, I know with the links, sorry for that, the Zoom setting that you cannot easily copy them. If you actually click on the links that we shared in the chat, it opens up the local browser window, and you can grab them there if you like. And we also do have links posted to the Meetup description for today. All right.
Awesome. Thanks, everybody.
Thanks so much, Damon. And with that, let's move on to the third talk for today. And I'll hand it over to Trevor, who will show us what Kale for Kubeflow is all about.
Awesome. Thanks so much. And thanks everyone for sticking around. My name is Trevor Grant. Here, let me share my screen. Boom. Okay. There it is. All right. So this is about me. My name is Trevor Grant. I'm from the Humboldt Park neighborhood of Chicago. This is a picture from the sledding hill around dusk. About this time of year, you get this cool effect where all the buildings light up orange. I thought it was cool. This is an about me slide from a talk I gave a couple of weeks ago. I'm the PMC chair of Apache Mahout. I'm also involved with the Apache Streams project, Apache Community Development. I'm a mentor on the Apache SDAP Incubating Project. From all of this ASF activity, you may have guessed I'm an ASF member. I am also author of Kubeflow for Machine Learning. Side work shouldn't define us, so my side hustle is an e-trike. And last but not least, I am the Director of Developer Relations for Arrikto, which, quick slug on our company, we do mini KF, enterprise Kubeflow, Rock, Kale, and Kale is what we're going to talk about today. However, I will do a quick drive-by pitch for my book. It's a great way to enchant your friends and enrage your enemies. Also, everything I'm going to talk about here is available in Arrikto Academy, or academy.arrikto.com. A lot of cool courses in there. It's a new launch we've done. So this entire talk is going to be a live demo. If you've ever done live demos before, you know that that is a recipe for disaster and you're doomed to fail unless you've got everything preloaded in a backup, which I do. So we may just work. Without further ado, then we'll jump into it. So it sounds like everyone here's knows Kubeflow, and I'm going to look at the chat real quick. Thanks, Chris, for the book slug. I'm going to assume people are at least passingly familiar with Kubeflow dashboards. The stuff over here is always going to look different depending on who installed your Kubeflow setup, but that's the gist of it. So this is a kind of an old Kaggle project. I need to move this so I can get out of the way. Okay, so this is a Kaggle project on predicting car prices. And the point of Kale is to make it really easy for data scientists to convert their notebooks into Kubeflow pipelines. That is the top level of what's going on here. So you've got a notebook. It's got a lot of typical data science stuff, even though this is obviously not super exciting. It's just predicting car prices from an intro Kaggle thing. But so this first step is just imports. And so you basically can annotate each step. Then that's what, oh, I'm sorry. You normally wouldn't get this. You get this little thing over here. You enable Kale, it turns it on. So first step is an imports function. Easy peas. Now, the second step is reading our data, and we will want to do that. So we create a step, we'll call it read. It does this weird thing where it wants to fight with me when I try to type stuff in. I'm not really sure what's going on there, but there it is. So this step isn't going to depend on anything. The next step, and while this is useful for notebooks, we probably don't need it to run in our pipeline, so we can skip that cell. And now our next step is going to be to clean the data. So we'll create a new step called clean data. I'm not this horrible at typing. It's running around trying to do its own thing. I think the naming function thinks it's smarter than you, which is tedious, but here we are. So the clean data step will depend on the data being read at that point. And so this is just this is inspecting the data. We can skip this step. And then this is also more data cleaning. Now, here's a cool thing. Since we don't have any other steps, we don't have to annotate this. And if we don't explicitly mark it as a skip step, it will just tack it on to the previous step. Also, you'll notice these markdown cells. Kale knows that markdown, there's no logical way to run a markdown cell on a pipeline. So these two steps will both just be part of the clean data step, which is what we want. Check in. And see. Also a clean data step. Now, this is just doing an inspection to see if there are duplications. There aren't, because I've seen this notebook 2 or 3 times. I actually had to rebuild this all this morning because I made such a mess of my other box. But so we can skip that. We can also skip this. But we will want to do this. And we'll leave that in the clean data as well. Now, visualizing the data, while again, very important for our for any data scientists looking through things, not important for a regular pipeline run. I see GH raise their hand. Go ahead. Or I'm not really sure how questions and answers work on this meetup. So let me see.
Anyone who has questions, feel free to put it in the chat so we can see it as we go along the talk. That's the best way.
Okay,
Thanks.
cool. Thank you. Yeah, so visualizations don't normally need to be created for every pipeline, though it is possible to do that. In this one, this is just some kind of welcome to data scientists, welcome to data science visualizations, look at your outliers. And again, I happen to know this because I've lived in this notebook for a long time and it's a whole thing. So I can just keep skipping cells. I probably could have done all this earlier. Oh, that was already skipped. And there were some insights, and yes, it's all very exciting to learn data science. Now let's get down to the modeling, which is a little bit more exciting. This is going to be our train test split, requires on the data being clean. Oh no, I wanted to do it up there. Shoot. Oh dear. Train test split depends on clean data. And again, just calling out some columns and whatever. Pretty sure we can skip just looking at the head. We can skip this correlation matrix. And if you run this whole thing, there's actually some very pretty, there's very pretty visualizations in here, and I'm kind of not doing this notebook justice because I know we're kind of over and I want to get everybody out of here quickly. Let's see. Cool. Okay, so we're on our train test split, which I'm going to leave this blank because this is really getting into the train test split. This is another import. So we'll just mark that as an import cell. And oh yeah, that's actually where our train test split happens. So now we've got a pipeline step of we want to train the GBMR. Never heard that one. And so to train this first one requires on the data being train test split. And then we will also train random forest. So the reason it's kicking around on me, in case you're ever doing this and like it's driving you nuts the same way it's driving me nuts. I don't know if you see, I keep like typing in letters and it's like, no, let's change the letters. I think it's trying to save every time a character goes in, which I've done enough front end to know that's not exactly a pattern, but it is what it is. So that's your random forest model. Wait. Oh no, that's good. This will be the train random forest model. Nope. Also requires train test split. So the idea here is we're going to do our train test split, and then we're going to do a side-by-side training of 3 different models: a random forest, an LGBM, and an XGBoost. Also train test split. Now, there is one other fun thing that we can do here. And I've got it preloaded so as to not take too much time doing it. Oh yeah, and you can see there's like all these cool visualizations that I'm skipping over, but again, proof that they did exist in there. I want this one. So we can also create a function cell. So if you've got like custom classes or custom functions or custom whatever, you can declare that in a cell and then call it a function cell. And then it will be imported into all of the other cells that run as well. And this may make sense a little bit more when I show the pipeline. So those are our functions. And I think the demo, or at least the class, like has you split a lot of this out of the other cells, but I'm doing a live demo, so I'm going to move fast because you don't want to watch me work on homework. And we paste that there. So to run this whole thing, then come over here and compile and run. Oh yeah, I gotta give it a name. So experiment, it's fine. Pipeline name, pipe 3. So the other cool thing it'll do here is if you have an error in your notebook, it will kick an error, but so you'll get the error before the notebook runs. You won't have to wait till your notebook or your pipeline is running before you get the error. Case in point here, RF model, what? Okay, I'm not going to bug shoot this whole thing because nobody wants to watch that. This is a version that I did it all, and when I was paying attention before, you compile the whole thing and run. Candidly, you end up picking up a lot of overhead when you do this because you're creating Docker containers for every step. And in a real pipeline, you would probably read your data, clean it. You could probably read, clean, and prep all in one step, especially with the cheap Python stuff we're doing here. If you're doing like some Spark ETL jobs, and the split really. If you're doing some Spark ETL, you might need to actually break those up into separate steps. Or if you were doing, if you needed to use different languages, for instance, let's say you wanted to do your data prep with Python, you wanted to actually do your machine learning with R. That's a whole thing you could do too. So you can run these, you get the logs. Again, you're going to see a lot more log and output here because of Kale's doing a lot of fancy stuff in the background, as well as Rock is screenshot or snapshotting your data. Then this again. So yeah, clean split, it trains the 3 models, and then Zoom is killing me. And here's the output. I probably should have put a little bit more better labels on there, but here it is. And so there's your data. So that was my super fast run through of what Kale is. And again, really just to help data scientists create their own pipelines a lot simpler and easier. If you've created this doesn't probably seem that very magical unless you've tried to create pipelines from scratch before. This is the equivalent of YAML files in Kubernetes being auto-generated for you versus hand rolling them. I mean, you can hand roll them. There is no magic here, except it is magic if you've ever done it the hard way. This does seem quite magical. So with that, I will open up to questions if there are any. And I've seen some hands raised, so I would imagine there are.
Thanks so much, Trevor. Yeah, anyone who has questions, post them in the chat window, please, so we can get to them.
Yeah, so Trevor, so does this actually generate a pipeline.zip and all that stuff? Yeah, it has to, right?
I believe so, yeah, because it's in here. And now to download that is probably a good question that I should have known. And it's killing me too, because I've got all this whatever Zoom stuff in the way. But it surely does. And I can get back to you with where that would be put out at. So yes, but by virtue of the fact that it's in here, yes, there's a pipeline zip somewhere happening under the hood. I just don't happen to know off the top of my head where it's at.
Right. Okay. And Lekan is asking.
Oh, yeah, we do have a few questions coming in. How do I schedule a pipeline, and where do you specify the train test split?
So I'll do the train test split one first. Let me continue to get this junk out of my way. So the train test split, and I'm kind of rolling back now to my pre-rolled one, but I made a train test split. No, further down. Where did it go? There was the prep data. Here we go. The split data cell, a pretty simple train test split. Again, just using sklearn. There was nothing fancy there, just calling out as a step. And also why I was saying, like, you're taking on a lot of overhead on each one of these steps. In a real world scenario, like, that does not need to have its own Docker container. You could probably crash all 4 of these at least down into one pipeline step, but it doesn't look as cool for demo output. As far as scheduling, now that is a good question.
I think through the, can't you schedule it through the Kubeflow UI once?
I know you can do that. I was going to see if, I didn't know if there was a, I haven't taken this thing out enough to play with all the bells and whistles to know if there's any special Kale thing. But I think, yeah, the Kubeflow UI would be the way to do that as well.
Mm-hmm.
So in that case, so yeah, you would schedule just like any other pipeline would be scheduled.
Got it.
So
Okay,
you can
and
take a recurring run here, or you can do it one-off. Well, you'll probably do it one-off. I guess you would do it recurring if you wanted to be scheduled.
yeah. What was the parameters link down below that?
Down here.
Yeah.
So what, all right, this can take I'm gonna have to take a step back to like explain what Rock is, but I can go fast. So Rock does, it does snapshots. So for example, if on that experiment, I wanted to load, let's see, if I wanted to load see what the state of the data was from, let me see, like after the split data or something like that. Like if I wanted to see, okay, which records were in train versus which were in the test set versus what were in the validation set, I could load the data snapshot from this point and like manually inspect all those variables. So you get, like, you know, these will all look familiar from earlier as variables I declared right here. So I can load this and I'll just basically be loading the environment right there, and I can see, okay, cool, what's in X, what's in Y, what's in YT, what's in XT, and I can get a better feel for what's going on in my job. So to come back over here to the no, not what I wanted. Great. So the parameter there is going to be, nope, that's not what I want either. That parameter was the Rock snapshot that was backing all that. Is basically, that was something that Kale built into it initially.
So Rock is a separate project. Rock is like a lineage type thing.
Yep, it's kind of like Git for data, for lack of a better word. It'll allow you to snapshot and version your data as it was going through. So you can do postmortems and understand, you know, if you've got a model that throws some exceptionally weird numbers out, you can go and look at like, okay, cool, what was going on in that model? Like, was it a data issue? Was it random C that just, you know, every once in a while you get a bad model, or what exactly happened there?
Okay. And you mentioned that one of those nodes in the pipeline could be like a Spark transformation, right?
Yes.
And that would require that the image has Spark installed. And where do we specify how much CPU and, you know, how much memory each of those steps? Because they just end up running as pods, right?
They do. So I have this whole talk I gave for FOSDEM is about running Spark and Kubeflow. There were some Spark and Kubernetes updates that happened right after I did this talk. I spent more hours than I'm proud of last weekend trying to bug shoot the whole thing. I finally got it ran down to the point where, so you can't use a Spark job in Kale yet, though I'm going to be working with the engineers hopefully over the next couple months to work that in. But to run a Spark job from Kubeflow, you need a resource op. And Kale in this style only makes container ops. Now, Kale does have an SDK that will allow you to make resource ops, but there's no fancy buttons for it at the moment. So it's going to be working with product managers, working with engineers to figure out how to do this and how to make it user-friendly. So and in that resource op, that's where you specify how many CPUs, how much memory, how much like that. But again, I'm hitting an issue. From what I can tell, the Spark operator in Kubeflow, people hasn't, I don't know if it's been updated a lot, but it seems like it's still on 2.4.5, which for Spark is kind of old. There were some Java hangups. I'm still tracing the bug, so I don't want to call it on any specific thing because I don't know what it is yet. But I'm hitting the point where I've got it to now is I can fire up the job, the driver runs, the driver fires up all the executors, and then the executors can't find the driver and they get lost and they're giving me connection timeout resets. So
yeah, I'm debugging something similar with Ray.
Yeah,
the leader launches and then the workers launch, but they can't quite find each other, so they all just
the joys of
nothing.
distributed computing.
And Kubernetes.
Yep. Yeah, just layer on layer on layer of obfuscation.
And these resource ops. So I'm familiar with the container op, but what's a resource op?
So all right, I'm going to kind of go off script here and go to my GitHub. Oh, also while I'm just typing, if anybody ever wants to ask me questions or get a hold of me, I'm generally available in the Kubeflow community Slack channel or various mailing lists, or I can give you my email number in the chat as well. But so nope, not what I wanted. That's going to be the actual thing. You can see this is a very professional GitHub repo I've got going on here. And that won't work. So you can declare manifests with JSON in addition to declaring them with YAMLs. People normally do it with YAML. However, JSON is a legal way to declare it. And so you basically make a Python dictionary. And so here's it's the same specs as you would have for another Spark job on Kubernetes. And then, so this and this and this. And I was saying earlier, like Kale doesn't seem magical unless you know what a pain it can be to actually do resource or to do pipelines otherwise. So if you're doing pipelines otherwise, you have to declare you have to call out that you want you want a volume. This is what a container op looks like. And then this is how you declare a resource op with just a regular pipeline. So it's a little bit more low level.
Container ops, and so okay, right. So after, okay, I see. So you've created some custom resource that you want to trigger. In this case, it's the Spark operator, the Spark resource operator for Kubernetes.
Mm-hmm.
And who maintains that? The Spark operator?
I know, right? I want to get all of them too. I don't know. It, like I said, I've hit a lot of errors that a lot of people hit back in 2020, and then everyone seemed to say they went away. So I'm not sure if everyone just gave up or if there's something that's misconfigured on my system.
Yeah, no, I had problems with it too. And then Holden, one of your co-authors for the book, up there behind you, I thought she was involved in it early when she was at Google, and then
she was actually Holden was the one who wrote this whole thing for me.
Oh, gotcha.
Yep. So she was, and then I'm not really sure if what she's up to with it now, though.
Yeah, because she's over at Netflix now, right?
Did she get back to Netflix? Yeah, it's hard to keep up with her, but yes.
Wait, did she leave Netflix? Did you hear she left?
I don't know. I just have a hard time keeping up where she goes. She moves a lot.
Yeah. Okay. Interesting. Yeah, Trevor, thanks so much. Does anyone else have any questions? Yeah, we're like 2 hours over or something crazy.
Right.
It's the holiday special.
Yeah, here, one sec. I'll put my email in here. And this is my personal, so I'll actually read it. And then the Kubeflow Slack community Slack, I think it's just Google it. Or it's kubeflowslack.com, but like you need to go on the community page to get like an invite. They've got some sort of rigmarole set. I don't know if you've all seen that before. You got to go to the community page and then send yourself an invite link, and it's all that kind of nonsense. And I don't want to break it on my machine, so I'm going to turn it off. Yep. And yeah, you'll end up on the Kubeflow page, and then has some automated thing to send you an invite. Cool. Well, thanks so much for having me out. It was fun to talk.
Yeah, thanks so much for joining us, Trevor. Really, really great to talk more about Kale here and see it in action.
Cool.
All right. And just before we wrap, just a quick plug for our next month webinar. We do have the agenda already published. If you check us out on meetup.com, we're having Josef and Simon from the BMW Group, Munich, Germany, joining us and presenting their cloud data hub they developed in-house to make the BMW Group's data actionable. So really great talk. They also presented at the AWS re:Invent conference back in December. So we're going to have them joining us for the March webinar. And we also have a session and a demo on Amazon Redshift Serverless. So make sure you're bookmarking our next month meetup, and hopefully we'll see you there. Thanks so much for joining us today.
Hi, everyone. Thanks.